What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at exercise 41 of our Python exercise tutorial series. A reminder, guys, I should mention that, from exercise 41 onwards until further notice, we will be working with exercises that deal with functions in Python. So let's get to it. Exercise 41. Write a function that takes the lengths of the two shorter sides of a right triangle as its parameters. Return the hypotenuse of the triangle computed using Pythagorean theorem as the function's result. Include a main program that reads the lengths of the shorter sides of a right triangle from the user, uses your function to compute the length of the hypotenuse, and displays the result. Okay, guys, so for this exercise, right, it has to do with functions, and essentially we are calculating the hypotenuse of a right angled triangle. So the theorem of Pythagoras is a squared plus b squared equals c squared. I should mention now though that with regards to the exercises, as I mentioned in a previous video, right, the exercises are going to get much more, I wouldn't say complex, I would say sophisticated, with regards to the syntax that we'll be using and so on. Like, this is the first time we are going to be using functions now. So that obviously tells us that if functions are being used, the amount of program logic kind of increases, right? That's the whole reason for using functions. So we can enclose the logic in a function so we don't have to basically repeat ourselves or recode, have duplicated code. So the point I'm trying to make now is that I will be reducing the amount of explanations that I do even further, because in the previous exercises that we dealt with, it was about looping, if I'm not mistaken, for loops and while loops and so on. I did explain like every, or tried to explain every portion of code and what it does. So in this case now, I'm assuming you are familiar with the Pythagorean theorem, so the theorem of Pythagoras. And at this point, I assume you are familiar with the concept of modules and so on. One thing I should mention also is that I did not create a tutorial that speaks about modules on my channel. So the idea though is that it's nothing too difficult. I actually do have a PowerPoint slide on modules, but it's actually not completed. One thing I recommend though is just YouTube. You'll find you are sure to find like a 5-minute video that explains the concept of modules in Python. Essentially, I can give you a small rundown. Basically, a Python script, a module is literally a Python script, right? And what modules do is they help us to break our code down into several scripts. So, if we have a super large program that we've developed, let's say we developed our own software, our own operating system. Now, logic will tell us that we're not going to store all the source code, right? The Python code of that operating system software in one script, right? So one script, that script will have maybe 500,000 lines of code. That's ridiculous. We won't do that. Instead, what we'll do is we'll divide the code. So maybe 25,000 lines of code spread across several files. And each of those files will be called a module. And in the main Python file, the one that everything stems from, essentially what we'll do is we'll import all of the other files, right? We call them dependencies. So we'll import them into the main script in order to use it. And by importing it, it's basically telling us that we have access to all of the lines of code and functions, anything, literally anything and everything that's Python code that's inside a module. By importing it, we can access it in our script. So that's really just a sort of overview of modules. And as you guessed it, the way in which we import modules in Python into our script is by using the import keyword. So there's a module called math that's basically built into Python. It's been put there by the Python developers for us to use. It contains super interesting math functions, and features. So stuff that you'd really have, basically stuff that you'd have to think the logic through. It's already really readily available for us, right, in these modules. For example, from math, we'll be using this function called square root. Square root is basically, as the name implies, it allows us to find the square root of a number that we pass in it. So, okay, I actually typed this wrong. So we'll do from math import square root. So there's nothing, not that of a big deal here. Basically, we can import math, right? Math, by importing math, we are calling on every single line of code in the math module or in the math file into our script. But now, what's the point of calling everything in the math module when all we are looking for is one specific function that's defined in that file, specifically the square root function? So that's why we do a from math import square root. It's basically us knowing exactly what we need to use, and that's why we specify from a module import certain feature. So that's what we did. Now, square root, you know what square root is, basically to the power half. So like 2 to the power 1 over 2. Let's actually do 4. 4 to the power 1 over 2 is 2, and if we do a sqrt of 4, it also gives us 2. So that's the efficiency of the math module. We don't have to raise stuff to the power and so on. Just call the function, pass your value, and you'll get an answer. So let's move on. I'm going to begin by defining. Again, I should mention, for all these exercises that we've been looking at so far, there's more than one way to do it. I'm just here to give you a guide. So we are going to definitely need a function. It's going to be the main function, right? Because the calling of the calling of input and taking in of input and so on is all done from the main function. So they even told us, right? A main program, read the lengths of the shorter sides of a right angle triangle. So basically, a triangle has three sides. One is the hypotenuse, the other two are the adjacent and opposite sides. So let's read in values for the adjacent and opposite sides. Define main. Adjacent is equals to int. Now I won't int this, and maybe float that to give the user flexibility. Please enter the length of the adjacent side of the right angle triangle. So I'll copy that to save time, and we'll call this opposite, because the sides of a right angle triangle are basically A, O, and H, or at least that's how we learned it in South Africa. Adjacent, opposite, and hypotenuse. So that's good. We need to change something here. Yes, this should be opposite. Okay, that's good. And what we are returning is, oh, actually nothing from here. The returning can be done from the other function, which is basically our hypotenuse function. That's fine. Within the main function, we can actually send output to the user. So the main function in most Python programs will be responsible for taking input and giving output. So processing can be done by all these smaller functions that we define along the way. So let's say the hypotenuse, or let's say the length of the hypotenuse, longest side of the right angled triangle is, that's good. So we leave that as that for now. That's fine. So moving on, one thing that we can do now is, let's quickly come up here above the main function, and it's time we define a function that's going to perform logic for us. By logic, I mean the processing of the input. So this we'll simply call hypotenuse. It's a hypotenuse function. It's taking in two parameters. Again, I'm not going to be explaining, what parameters and stuff are. I assume you've went over the tutorials on functions on my channel, or just in general, you have an idea of what and how functions work, what functions are and how they work. So hypotenuse, adjacent, opposite, that's fine. So the way in which we calculate the hypotenuse of a right angle triangle, we'll call that square root function from math. And the reason being, when you shift everything to one side in a squared b squared equals c squared, or a squared plus b squared equals c squared. Yeah, so basically when you shift everything to one side, the c squared, so the square gets carried the other side and it becomes a square root. So that's the basic reason for the square root, right? And we'll do adjacent to the power 2 plus opposite to the power 2. That should be good. So moving on, this function can return hypotenuse. So it's returning this variable here, or that object, or whatever you want to call it. And to what? In this case, it'll return it to the main. So what we can do is, yeah, really all we need to do is just call hypotenuse and pass in our parameters, or our arguments rather. So let's do. So I will provide maybe formatting in percentage dot 2f. That's our decimal placeholder. And yeah, from within this, all we have to do is call that hypotenuse function, adjacent, opposite. That's good. So we actually saved ourselves some time here in this specific scenario, because we called our input variables, or we gave the input variable the same names as the parameters. So that saves time. If we call this adjacent one and opposite one, then we'd have to change it from here, right, within the parameters. So that's why I assume you understand parameters and arguments and so on. And this is really all. But as you know, if we don't call that main function, nothing is going to happen. Let's prove it. So see, everything executed, but there was no output. So let's call that main function. And essentially by calling the main function, we see that within the main function, the hypotenuse function is called, which means it will jump to the top. And the hypotenuse function is returning hypotenuse, which means that we are going to have a value here. And essentially, we will place it in the placeholder. One thing that I noticed now is that I should have specified, using a percentage sign. So let me correct that. Yeah, that's it. Instead of a comma, there should have been a percentage sign, because we've been working with placeholders for quite some time. The percentage sign after the string basically denotes formatting that's going to follow for the placeholder. So let's run the program. This is interesting. Let's do interesting ones. Maybe 13 point maybe 45, and let's do 6.54, or let's do 6.75. And there we see it. The length of the hypotenuse of the right angle triangle is 15.05. Yeah, that's it. We've successfully completed exercise 41 of our Python exercise tutorial series. Let's do this one more time. And yes, indeed, we do get. And how we know this is right is because, the value it's returning to us is larger than the adjacent and the opposite side. So that's how you know it's actually the hypotenuse that you are working with. Because in a right angle triangle, the hypotenuse is the longest side. So with that, guys, I do hope you found this video interesting. Personally speaking, I did. I found it super interesting. Just talking about the logic and the way in which we go about doing and setting up our Python code is very insightful. So with that, thank you guys for watching till the end of the video. Do make sure to leave a like, subscribe to the channel, and I'll see you in the next YouTube video.